Hello there. I'm going to give you some notes over some trigonometric equations. This is section 6.2, which is actually a continuation of some things that we had been doing last week. So let's just go ahead and get started. If you notice here, we're going to solve some equations that look something like this. Here it says the sine of x equals radical 3 over 2. So what we're looking for is a value whose sine is radical 3 over 2. Now, if you remember, we can actually relate this to the inverse signs that we talked about last week. We got a lot of the same words were used. What we're going to do is we're going to answer these in terms of both degrees and radians. So we're going to do both those today. So we're figuring out where is the sine radical 3 over 2. Well, if you think about this, the sine is which value? Is that the x or the y? Good, that's the y. There are actually a couple places on the unit circle at this coordinate, that coordinate of 1/2 radical 3 over 2, and at this coordinate over here, where it's negative 1/2 positive radical 3 over 2. Now, I know you're thinking about the fact that the inverse signs we'd get one answer. Well, that was true. However, these are solving equations that are a little bit different. So we actually do come up with a couple of solutions. Those solutions will be this angle right there, which if I go in degrees, that is 60 degrees. And this angle over here, which if you look at a unit circle or think about your unit circle, is 120 degrees. So those take care of the degrees. We're also supposed to go in radians. So this angle in radians is pi over 3, and the other angle is 2 pi over 3. So the x values that work for this equation would be these four x values. Looking at another equation, if we have the cosine of x equals negative radical 2 over 2, well, we're finding which value would that be? Would that be x or y? Good, that would be the x. And that is the coordinate remember there are three coordinates over here. The one that's right in the middle is the one where you have those radical 2's over 2's. So this angle right here is 135 degrees. So I could say x equals. And this angle right here would be 225 degrees. Okay, and then the radians for those, this first one was 3 pi over 4, where the second one was and is and always will be 5 pi over 4. Another equation where the tangent is radical 3. Well, I kind of have these memorized in a sense of what the tangents of some of these values are in radians. So I'm going to kind of cheat maybe and go ahead and talk about these in radians. I know that pi over 3 has a tangent of radical 3. And also, now we want that to be positive. Well, the tangent's positive here and here. So the first and third quadrant. The third quadrant angle would be 4 pi over 3. So in degree, that's 4 pi over 3, not 4 pi over 4. That would be silly. So this is 4 pi over 3. The angles there then in degrees will be 60 degrees as well as 240 degrees. All right, and just to confirm that, here at pi over 3, that coordinate is 1/2 radical 3 over 2. So if I put the y value over the x value, remember those 2's cancel out and that gives me radical 3. That's why pi over 3 works there. We can also do some things, sometimes we have equations that are not on the unit circle. For example, here we have sine is 0.65. Well, what I'm going to do on my calculator now, I'm not sure if you're able to see this, but I'm going to bring out my calculator here. I'm going to make sure I'm in the degree mode, because in the directions it does say to put this in degree mode. It says express degrees rounded to the nearest tenth. So in my calculator, I'm going to hit second sine of 0.65. Now you may want to try that as well. Make sure your calculator is in the right mode. And I get 40.5 degrees. So x is 40.5 degrees. Now, most of these will have two answers. Okay, we're figuring out where the sine is 0.65. Well, that'll happen here in the first quadrant. But that's also going to happen over here in the second quadrant. That's where a sine could be positive. That angle right there is 40.5. That is a reference angle. What I need to know is, what is this angle right here? So I'm going to take 180 and I'm going to subtract 40.5 so that I can see what that angle would be. What I'm getting is 139.5. So those are my two angles here. And again, notice how we said to answer these in terms of degrees. It doesn't say radians, so I'm going to leave that alone. Okay. Likewise, with the tangent being 5, well, I'm going to go to my calculator. I'm going to hit second tangent of 5. So I'm finding the inverse tangent of 5. I get 78.7 degrees. So 78.7 degrees is one of my values. I need to think about where would the other one be a positive 5. Well, tangent's also positive here in the third quadrant. So I'll take 180 plus that reference angle of 78.7. Okay, so I'm going to take 180 and I'm going to add 78.7. And I will get 258.7 degrees. Okay. If I were to find a secant, well, if the secant of an angle is 3, that means the cosine of that angle is 1/3. Okay, so as far as this is concerned, I could go through the same process that I just did. I'm going to save some time here for you. And you would just go ahead and hit second cosine of 1/3, and that will give you that angle. Okay, so actually I will go ahead and do this. So second cosine of 1/3, the angle that I get is 70.5 degrees. So x would be 70.5 degrees. And then to find that other angle, I'm going to subtract that from 360 because where the cosine is positive is going to be in the fourth quadrant. So I get 289.5. Okay, again, the reason for that is cosine's positive here in the first quadrant. It's also positive in the fourth quadrant. So this is the angle I need. The 70.5 was simply a reference angle there. Okay, and that's going to be your homework assignment. Good luck and be good to people.